Download this code from codegive.com, link in the description below. Akka random failures, simulating fault tolerance in distributed systems. Akka is a powerful toolkit for building concurrent, distributed, and resilient message-driven applications. One of its core strengths is the ability to handle failures gracefully. In realistic distributed systems, failures are not just possible, they are inevitable. To build robust systems, you need to design and test how your akka actors respond to unexpected events like network partitions, actor crashes, and resource exhaustion. Simulating random failures is a valuable technique for validating your fault tolerance mechanisms. It allows you to expose your system to failure scenarios in a controlled environment, identify weaknesses, and refine your error handling strategies. This tutorial will explore different ways to introduce random failures into your akka systems, covering both theoretical concepts and practical code examples. We'll cover 1. Understanding akka's fault tolerance mechanisms * supervision strategies and death watch. 2. Techniques for simulating random failures * random actor termination * killing actors at random intervals. * message dropping * randomly discarding messages. * introducing latency * simulating network delays and slow responses. * throwing exceptions * simulating unexpected errors within actors. 3. Implementing failure simulation with akka test kit and Scala test * creating integration tests that simulate and verify failure scenarios. 4. Best practices for failure injection * strategies for making your failure injection realistic and effective. 5. Examples of failure scenarios * a set of common distributed system failure scenarios and how to simulate them. 1. Understanding akka's fault tolerance mechanisms. Before diving into failure simulation, it's crucial to understand how akka provides fault tolerance. The two key mechanisms are * supervision strategies * each actor has a supervisor, which is responsible for deciding what to do when a child actor throws an exception. * supervision strategies define the actions to take. * resume * the child actor resumes processing messages from its current state. * restart * the child actor is stopped and then recreated, losing its internal state. The pre-restart and post-restart methods can be overridden to handle state persistence or initialization. * stop * the child actor is permanently terminated. * escalate * the exception is passed up to the supervisor's supervisor, allowing the fault to be handled at a higher level. * supervision strategies are defined in the supervisor's supervisor strategy method. * death watch * death watch allows an actor to monitor another actor for termination. * when a watched actor terminates, either due to an exception, being explicitly stopped, or failure of its node in a cluster, a terminated message is sent to the watching actor. This enables the watching actor to take appropriate actions, such as recreating the failed actor or notifying other parts of the system. 2. Techniques for simulating random failures. Now, let's explore techniques for introducing random failures. Random actor termination. This simulates an actor crashing or being killed unexpectedly. We can achieve this by injecting a probability of termination in an actor's message processing loop. In this example, failure rate determines the probability of the actor throwing an exception and causing a restart for each received message. Message dropping. This simulates network packet loss or messages being discarded. We can randomly drop messages within an actor's receive method. The drop rate controls the probability of a message being ignored, dropped. Introducing latency. Simulates network delays or slow responses. We can introduce delays before sending responses or processing messages using akka.pattern.after. This actor introduces a random delay between min latency and max latency before sending a response. Throwing exceptions. Simulates internal errors or exceptions occurring within an actor's logic. We've already seen this in the random actor termination example. You can also create specific exception types to test your supervision strategies. 3. Implementing failure simulation with Akka test kit and Scala test. To verify your fault tolerance mechanisms, you'll want to use Akka test kit and a testing framework like Scala test to write integration tests that simulate failures and assert expected behavior. Here's a basic example of how to use testkit with Scala test to test the unreliable actor from earlier. Explanation **** We extend testkit to get access to testing utilities. ***implicit sender automatically makes the test itself the sender, for messages. *** We create an unreliable actor with a high failure rate. We send a message and use expect message to assert that the actor eventually processes the message successfully. The expect message will retry until it either receives the expected message or times out. Because of the high failure rate, the actor might restart multiple times before successfully processing the message. The supervision strategy ensures that it eventually recovers. Key considerations when writing tests ***. Timeout use expect message, timeout, expected message, or within, duration. To avoid tests hanging indefinitely if the system fails to recover. Supervision strategy verification assert that the supervision strategy is correctly configured and behaving as expected, example restarting the actor a specific number of times. You might need to use test probe to intercept messages sent to the supervisor. State verification after a recovery, verify that the actor's state is consistent and that it can continue processing messages correctly. Concurrency be aware of potential race conditions when simulating failures in a concurrent system. Use appropriate synchronization mechanisms if necessary. 4. Best practices for failure injection. Control the scope. Be precise about where you inject failures. Isolate the components you want to test and avoid introducing failures that could affect unrelated parts of the system. Use realistic failure rates. Base the probabilities of failures on real-world observations or estimates. Don't just use arbitrary numbers. Consider the MTBF, mean time between failures, and MTTR, mean time to repair, for your system components. Simulate different types of failures. Don't only simulate actor crashes. Also, consider message loss, network delays, resource exhaustion, and corrupted data. Automate failure injection. Integrate failure injection into your automated testing process so that you can regularly validate your system's resilience. Consider edge cases. Think about less common failure scenarios that might be difficult to reproduce manually. Use logging. Log failures to help diagnose issues and understand how your system behaves under stress. Monitor metrics. Track key performance indicators, KPIs, such as latency, throughput, and error rates during failure injection to identify potential bottlenecks and performance degradation. Property-based testing. Explore property-based testing frameworks like Scala Check. These frameworks can generate a large number of random inputs and failure scenarios, allowing you to test your system more thoroughly. 5. Examples of failure scenarios. Here are some common distributed system failure scenarios and how you might simulate them in Akka. Network partition, split brain. Simulate this by temporarily disconnecting nodes in an Akka cluster. This is challenging to simulate perfectly within a single JVM. You might consider running multiple akka cluster nodes in separate JVMs or Docker containers and using network emulation tools, example TC on Linux, to create network partitions. Test how your system handles data consistency, leader election, and conflict resolution when nodes are isolated from each other. Actor crash during processing. Use the unreliable actor pattern to randomly throw exceptions while processing messages. Test your supervision strategies to ensure that the actor restarts correctly and continues processing. Message loss. Use the message dropping actor pattern to randomly discard messages. Test that your system uses acknowledgements, retries, or other mechanisms to ensure that messages are eventually delivered. Slow network connection. Use the latency actor pattern to introduce delays in message delivery. Test that your system can tolerate slow connections and avoid timeouts or other errors. Resource exhaustion, example thread pool saturation. Create a busy actor that consumes a large number of threads. This can lead to thread pool saturation and prevent other actors from processing messages. Test how your system handles back pressure and avoids overwhelming the system. Akka streams are an excellent tool for managing back pressure. Database unavailable. Simulate a database outage by throwing exceptions when attempting to access the database. Test that your system can handle database unavailability gracefully and provide a fallback mechanism, example caching or alternative data source. Complete example, combined failure simulation test. This example combines several failure simulation techniques in a single test case. It sets up a system with an unreliable actor, a latency actor, and a supervisor that monitors for failures and restarts the unreliable actor. Key takeaways. Akka provides powerful mechanisms for building fault-tolerant systems, including supervision strategies and death watch. Simulating random failures is essential for validating your fault tolerance mechanisms. Akka Test Kit and Scala Test make it easy to create integration tests that simulate failures and assert expected behavior. Careful planning and realistic failure models are crucial for effective failure injection. Don't forget to test various types of failures, including actor crashes, message loss, network delays, and resource exhaustion. This tutorial provides a solid foundation for simulating random failures in Akka. Remember to adapt these techniques to your specific system and failure scenarios. By proactively testing your system's resilience, you can build more robust and reliable distributed applications. Good luck.